All right, second to last one here. We're in the home stretch. Still with RBD. We're looking at the copy on reads for clones in the kernel RBD clients. This was Chen and Wang. So if you guys want to give us a overview of what you had for the blueprint.
Yes.
All right.
So Chrome just told me that the pad.ceph.com is a phishing website.
Yeah, it's based almost entirely on the URL. We had that earlier for the security one as well.
All right, or reported as an incorrect warning.
Yeah, we did that too, and that's how we found out that it was just because it said certain things in the URL. All right, Min, go ahead and take it away.
Okay. We have just discussing this software before. The basic idea is that we have the same algorithm implementation in librd copy and read. So I just describe it again. First, we need to start the child object before the code. We don't know if it exists or not. Usually, when there is we haven't flattened the child object will don't exist, so the client will send the request to its parent. In kernel RBD client, the function RBD image object request submit will process all the state. When client read the object from the parent, it saves its content in memory, and it will write it to the parent. And so when you write it is successful, the copy on read action is over. So that's all. Okay. I noticed that there's a blueprint object map. Is that useful or to copy and read? Josh?
Yeah, so it's useful in the same way that to copy and read that it would be to know what copy and write, just being able to tell which objects exist already or not, and optimizing the process slightly by being able to tell when parent objects exist. You can go and read them immediately instead of having to go through an extra round trip to read those. There's no it hasn't been implemented or started being implemented on the current client at all yet. So and it's kind of separate. It can be used when it's there, but it can be implemented after copy and read there too. So they can go in either order. There's no dependency. think that the basic structure makes sense. You just need to add something to keep track of the outstanding requests, similar to what you did in user space, and make sure the kernel device waits for all those pending requests to be completed before it's closed. There's already some reference counts that we can use for that.
Keep happening.
Yeah, Ilya, you around?
Yes.
Do you have any thoughts about this?
Well, there hasn't much changed since the last CDS in those paths, because I was busy with bugs, and there was not much progress. I'm hearing a horrible echo. It's better. So there wasn't much progress with the fancy striping, so all the paths are pretty much the same. We merged discard, that changed a few things, but largely everything's the same. So what we discussed last time still applies. As far as waiting for requests to finish, that I think that may require some thought, because we don't even do it for writes properly, as far as I can tell. So
I think we do it kind of indirectly now by checking when there's still a reference to the device, don't we?
Well, yes, but that mechanism is, I think it's not entirely. For example, well, it sort of works, but for example, on refresh, there is no way to handle errors on refresh, so we can just stop I/O, and in general, it would be nice to have to separate the two things. So it would be nice to be able to stop I/O without unmapping an image. That will allow us to handle errors in refresh. That will also open up. So it's basically be a lot simpler, and so that's something that perhaps could have been done alongside, but that's totally separate from copy and read. So we should just submit the patches and see how it goes.
That makes sense to me. Min, do you have any questions?
Yes. Is there a plan to implement copyright in Kernel RBD? Because there you plan to you use the object map.
Well, I think Josh. Yeah, go ahead.
I think they serve kind of different purposes. Like copy and read lets you flatten the image while you're reading it to save I/O, and while you're basically doing an asynchronous button. Whereas the object just allows you to do reads more and general I/O more efficiently. So I see them as kind of two different purposes. So it makes sense to have both of them, I think.
And as far as the kernel implementation, I think the user space implementation hasn't been merged. So the pull request referenced in the in the blueprint is the old one. There is a newer one from September something, and I would really like to see it merged because otherwise I can't validate. So the first thing for you would be to push the user space pull request so it's merged, because otherwise I'll have a hard time reviewing kernel patches.
What is the status of the review on the user space one, Josh?
The conversation has 0 comments. So.
Yeah.
Yeah, I need to look at it again, but I think there might still be some issues to fix up.
Okay.
In terms of the fancy striping, which wouldn't apply to the kernel case, but it's a little complicated.
Yeah. Okay. I mean, I had cosmetic comments on the previous one, but it's all.
Especially if it relates to the fancy striping, it needs to be merged in the user space first, because those two are likely going to race. I want to finally sit down and start working on it because it's been going on for a long while. It really needs to be merged in the user space before it's submitted to the kernel.
Yep. Well, I think that's mostly just Josh, right? I think Mina submitted the patches, so that falls in our court.
Yeah. I'm sorry, it's been there for a while. There's been lots of things going on, unfortunately.
Giants out. Yay.
Yes.
Okay. I just one really quick question. When the copy on read is triggered, the original read will proceed as normal, but then immediately behind it there's a copyet that follows it. Is that how it works?
Yeah, that's the idea.
Okay. Cool.
So the copyet is asynchronous.
Got it. Okay. Cool. Sounds good.
Is that it for this one?
I think so.
Short.
Yeah, pretty good.